What's up? I'm Vin, and today I want to go through the 2012 AP Calc AB Calculator Multiple Choice section. So let's get started. And up first, we have question 76. We want to know for which of the following values of x is f prime both positive and increasing. Well, if f prime is positive, that tells you that f of x has to be increasing. So this means f is increasing, and we'll just abbreviate this. And then if f prime itself is increasing, this one here, this last piece, means that f double prime is greater than 0. And what does that mean? Well, f double prime greater than 0, and let's just make that a little bit neater, tells us that f is concave up. So we'll just abbreviate that, concave up. So what does it look like if something is increasing in concave up? Well, concave up just means the curve is smiling. So when you're on the increasing part of it, this is this part of the concave up curve. So it's the part of the smile that's going up. So if we look at all of this here, the curve is concave up at this section of the graph. But at which point in particular are we on the increasing part of the smile? That's going to be here at point E. So this is going to correspond to choice E. Question 77, we have a continuous function on the closed interval from 2 to 4, and we're given these two function values. And we want to know what's guaranteed by the intermediate value theorem. So the way this theorem works is that when they tell you you have a continuous function, and I'm going to plot these points. So we have f of 2 is equal to 10. And let's say that's over here. We're not going to necessarily draw this to scale. And then f of 4 is equal to 20. So that would be up here. That with intermediate value theorem, whatever your two function values are, as long as your function is continuous, you have to pass through every y value between 10 and 20. So when I draw this out, this could look a number of ways. But one thing that's guaranteed by intermediate value theorem, that as long as your function is continuous, we can't skip any y values between 10 and 20. So this is definitely going to be choice A, because f of x equals 13. Notice 13 is between 10 and 20. Has to have at least one solution. We cannot skip 13 on the way from 10 to 20. So this is definitely choice A. For question 78, we have a lot going on. We have this graph crosses the x-axis at one point between 0 and 1. And we want to know what is the slope of the graph at this one point. So let's say that it passes the x-axis at x equals c. So let's say this occurs at x equals c, that the function value at c is equal to 0. Well, what we're trying to find here is the slope of the graph at this point. So we want to find what is f prime of c. So we'll switch over to the calculator view and we'll trace the root of this and then plug that into the derivative. So to get this root, we're going to go over to the y equals, and we're going to graph e to the tan x, and then make sure we get out of the exponent, and we have minus 2 after this. And they gave us a specific interval. They said that the root was going to occur between 0 and 1. So we could change the x minimum to 0 and the x maximum to 1. And now we graph this. And notice there's our root. So we press second trace number 2 to find the 0. And notice we're a little bit in the negative. We hit enter once. We scroll to the right. Now we're in the positive. And there's our root right here. So if we press second mode to go back to the main screen, we could press second minus sign. And there's our answer. We could store this as the letter A, and now our goal is to find the derivative of our function at this value of x. So we could press Math 8 to take a derivative with respect to x. If we don't feel like retyping the whole function in, we could press vars, go to the right, go to function y1, and it's going to retype the function that we already have typed in y1. And now just press alpha math to put the letter A in, which we stored our solution 0.606 in there. So now we just plug this into our derivative, and our slope is going to be 2.961. So 78 is going to correspond with choice D. So for question 79, we're looking for the average velocity of the particle from t equals 0 to t equals 8. And for this question, we have to know this formula, the average function value formula, which is 1 over b minus a, integral from a to b of f of x dx. And this tells you the average value of f of x. But for this question, we want average velocity, and the velocity function is v of t. And we're going from 0 to 8. So for this question, we're just doing 1 over 8 minus 0, integral from 0 to 8, and we're finding the average value of velocity, which is going to be given here. So now if we just look at the answer key, this is going to match up with choice B. But just know that in some cases, they may want you to expand this and say the antiderivative of velocity. So if we use the fundamental theorem of calculus, and usually it's part 1, but if we use the fundamental theorem of calculus, the antiderivative of velocity is position, and we would have x of 8 minus x of 0 divided by 8 minus 0 is 8. So just know this is the true answer, but this would be another potential answer that would count as the correct answer if we wanted to write it without an integral, if we actually wanted to expand this. For question 80, we have a graph of f prime, the derivative of f, and we want to know which of the following statements must be true. So for this one here, the key is for Roman numeral questions, you want to go through them one at a time and say if each Roman numeral is true or not. Now for Roman numeral 1, we have f has a relative minimum at x equals -3, which is over here. Now be very careful. This is a graph of f prime. So I'll write that extra bold. This is a graph of f prime, and we'll make that a little bit neater. So what that means is that if we're looking to see if f has a relative minimum at x equals -3, then we need f prime to go from negative to positive at x equals -3. And if we look at the graph here, see the graph at x equals -3 goes from under the x-axis to over. So this one is definitely true. So Roman numeral 1 has to be in our answer, which means that these choices are out, B and C. Now we have the graph of f has a point of inflection at x equals -2. So this is a dangerous trap because if you notice here, the graph of f prime is concave down and then it switches to concave up. But that would be, we would say the graph of f prime has a point of inflection at x equals -2. But they're not asking us to determine if the graph of f prime has a point of inflection. We want to say if the graph of f has a point of inflection. So this one is not true, okay, because the trap that they set is that f prime has a point of inflection here. You see it goes from concave down, the graph looks like it's frowning, to smiling at x equals -2. So this one is out. Now the graph of f is concave down on the interval from 0 to 4. This could be a little tricky to interpret, but f is concave down means that f double prime of x is less than 0. And another way of saying f double prime is less than 0 is that f prime of x is decreasing. So anytime f prime of x is decreasing, that means the slope of f prime is negative, and the slope of f prime is f double prime. So just rephrase this in your head. What we could say here, the graph of f prime is decreasing has the same meaning as f is concave down. So from 0 to 4, if we look at this, notice from 0 to 1, 2, 3, 4, up to here, if we follow the graph, see the graph is decreasing this whole way. The graph is going down, so if the graph of f prime is decreasing, that means f double prime is negative, so f is definitely concave down. So 1 and 3 have to be true. This is going to correspond to choice E. For question 81, we have water pumped into a tank at a rate of R of t, and the units are gallons per minute. T is the number of minutes since the pump was turned on, and this is an important detail. The tank already has 800 gallons of water when the pump is turned on, and how many gallons of water are in the tank after 20 minutes. So this is a massive topic for the AP test, that the integral of the rate tells you the net change of the function. So what we have is there's already 800 gallons in the tank at the start of the question, and now we're going to do the integral from 0 to 20 of R of t dt. Now the reason why we're integrating here and not just plugging in 20 is the units for R of t are gallons per minute, and the units for dt are minutes. So when we do gallons per minute times minute, notice that's just going to give us gallons. So we have the 800 gallons plus however many gallons are pumped in from 0 to 20. So this is going to be all calculator work. So right on the main screen here, we could do 800 plus the integral. We're going to do math 9, and we're going from 0 to 20. And then our integrand was the function R of t, which was 30. And we did parentheses, and we have 1 minus e to the negative, and we had 0.16t, but we'll use x. All right, so there's our function. We'll close the parenthesis, and then we'll exit, press dx, enter, and we have 1220.143. So the 1220.143, remember, they said here to the nearest gallon. So that's going to round closest to 1220, so this is going to be choice D. For question 82, we're given f prime of x, which is this messy function here, and we want to see where does f have a local maximum at x equals blank. So local maximum, you should be looking for where does f prime go from positive to negative. So this is going to be all calculator work. So for something like this, we're going to go to y equals, we'll clear out what we had before, and we've got square root, we got x to the 4th power. Now we get out of that, and we got plus 1. Now we can leave the square root, and we got plus x to the 3rd. And then the end of this thing is minus 3x. So this is already f prime of x. So once again, we're looking for where does f prime change from positive to negative. So I'll press zoom 6 here so we can get a nice picture of this. And notice we're changing from negative to positive at this location. But the positive to negative change is happening here between 0 and 1. So what we could do is, if we want to zoom in a little bit, we'll just go ahead and do that. We could just press zoom, and we could just press zoom number 2. And that gets us close enough. So we're going to do second trace. Number 2 tells us the root. And remember, we're tracing the root where f prime changes from positive to negative. So notice we have positive values of y. We press enter, scroll to the right until we go negative, hit enter a second time, enter a third time, and we've got 0.350. So the sign change occurred at x equals 0.350, and this is going to correspond with choice C. So for question 83, we have a graph of the velocity function. We want to know what is the best estimate of the distance traveled. So this is what we're looking for. Distance traveled from t equals 0 until the car comes to a complete stop. So for this one, there's not just one nice way of doing this. And what we could do is just go ahead and find the area under this curve. But once again, we're doing an approximation because we're doing the best estimate. So for something like this, we just have to get really close to the answer. And let's say I round this up to 50 and I do a midpoint Riemann sum with subintervals that are 2 units long here, so 2 seconds. And notice here that if we do 50 times 2, that's going to be equal to 100. And then on the next subinterval from 2 to 4. Oh, and be mindful, this is what we're approximating, the integral v of t dt from 0 to 8. So that's what we're approximating using a midpoint Riemann sum. And I rounded this up to 50. So this doesn't have to be precise. It just has to get us real close to the answer. Now for the next rectangle, between 2 and 4, the midpoint would occur at t equals 3. And that would bring us up to a height of 40. And our rectangles are all going to be 2 units wide. So if I do 2 times 40, this is going to be 80 feet that we're talking about here. And then the next one looks like it's at about 15. And if we do 15 times this distance 2 across, 15 times 2 is 30. And it's 30 feet again. And now for the last one, we'll go back to green here. This one looks like it's closer to, we'll round it up to 5. We'll say it's almost halfway, but it's a little bit less than halfway, but we'll just go ahead and say this is 5 up, 2 across, and 5 times 2 is 10. So now we just add those numbers together, 100 plus 80 plus 30 plus 10. We get a 0 here, and then we got 8 plus 3 is going to give us 11, plus 1 is 12. Carry the 1, and this is going to give us 220. Now 220 is closest to choice D here, so we're going to say choice D for question 83. For question 84, we're on this interval here, and we have f prime given by this function, and we want to know which of the following intervals is the graph of f concave down. So we're looking for where f double prime is less than 0, and for this we already have f prime of x, so we have to take the derivative of this function and look for where it's negative. Now for the calculator section of the AP test, don't waste your time finding derivatives by hand. We're going to do the derivative of f prime. And remember, the function for f prime, we had e, and it was a bit messy. It was e to the x to the 4th. And then we had minus 2x squared plus 1. And then outside of the exponent, we had an extra minus 2. And we're taking the derivative with respect to x. So we could just say x equals x. And the subinterval was from negative 1.5 to 1.5. So knowing how to type this in efficiently really does help. And here we are. So notice here, it looks like our second derivative is going to be negative from negative 1.5. It looks like to about negative 1. But just to be precise, we could trace the 0 to be 100% sure. So we get close here, and we hit enter before, enter after, and a third time, and notice our second derivative is negative from x equals negative 1.5 to x equals negative 1. And it looks like it's happening again from 0 to 1. So it'll be from negative 1.5 to negative 1, and then from 0 to 1. So this one is going to check out with choice D. For question 85, we have a graph of f prime, the derivative of f, and we want to know the function f has a local maximum at x equals. So for this one, local maximum tells us we're looking for where does f prime go from positive to negative. And this is a graph of f prime, and notice the positive to negative sign change happens at x equals 1, which is going to correspond with choice C. Question 86 takes up a lot of space, so we'll scroll down to look at the other answer choices. But right now we have f prime is positive for all real numbers. The integral from 4 to 7 of f is equal to 0. Which of the following could be a table of values for f? So when I read this statement here, f prime is positive for all real numbers. This means that f is always increasing. So we have to use this idea in the question. So if f is always increasing, we could use that to eliminate some choices. So notice choice A, the y values are going up, so we can include that in the next round. Here we go from -4 to -2 to 5, so that's a bunch of increasing values. But right away, see, we could get rid of choice C, because we increased from -4 to 6, but then we decreased to go from 6 to 3. So choice C is out. Choice D is not increasing from 0 to 0 to 0, so choice D is going to be eliminated. And then here we have 0, 4, 6. So these are going up. So far we have it narrowed down to 3 choices. But now we have to think about, how do we make use of this information? Well, for this information here, we have the integral from 4 to 7 is equal to 0. So if we have something that's always increasing, and this definite integral is equal to 0, that means that this curve has to start out negative at x equals -4, and then at some point it goes positive, because the area from -4 to 7 has to have an equal amount of area under the x-axis that it has above. Now, I'm not a great artist, so this looks like this is slightly more, but let's just say here these areas are equal and opposite, so they cancel out. So we're looking for a table that has negative y values and then positive y values. We need to be negative at x equals 4 and positive at x equals 7. So here, notice it's -0, so this one's out. This one starts negative at x equals 4 and winds up being positive at x equals 7. So this is looking like the answer right away, but now we look at the other answer choice and why it's no good. In choice E, we start at 0 and go only positive, which would mean the integral from 4 to 7 of f of x dx in this case would have to be greater than 0, so that's why choice E is out. So we are definitely going with choice B here. For question 87, we have a graph of f double prime, and we're looking at the space from -2 to 4. And for this question, we want to know, where is the function f concave down? So concave down means we're looking for where f double prime of x is less than 0. And since this is already a graph of f double prime, we're just looking for the negative parts of the graph, which are going to be here from -2 to -1. So we're between -2 and -1, and also between 1 and 3 the graph is negative. So when x is between 1 and 3. And now we just scan, this is going to match up with choice E. Question 88 is related rates. So we have a person who is 6 feet tall walking away from a street light at a rate of 4 feet per second. The street light is 15 feet tall, and what is the rate at which the person's shadow is lengthening? So we're looking for the rate. And here we could just label this stuff. So we have a 15-foot tall street light. This we could just label as a constant because the street light is not changing. Also, the person's height is not changing. So that could stay fixed at 6 feet. And now when the light shines down and hits this person, it's going to cast a shadow in front of them. So notice here the shadow is this part here. So this would represent the shadow. So we're going to need 2 variables here. We're going to call this space here x, and this one we're going to call y. So notice when they tell you the person is walking at a rate of 4 feet per second, that corresponds to x, because y is the shadow. So they're telling us here that dx over dt is equal to 4 feet per second. So what we're actually looking for is we're looking for what is dy dt. Okay, so we're looking for the rate of change of this. So assuming this is built well and the person is walking upright, they're going to form 90-degree angles with the ground. So what we have is, this is a similar triangles question, and I'm going to draw the big triangle. The big triangle is 15 feet, well, it goes up 15, and then across, be careful, if it goes over x and then over y, that horizontal distance is going to be x plus y. And then the small triangle we would be looking at is the one formed by the man and his shadow, or the person. So here, what we have is the person's height is 6 feet and their shadow is y feet long. So now if we set up a proportion here, this is going to be 15 over x plus y equals 6 over y. So now what we could do is cross multiply, and we're going to have 15 times y. So we'll write this over here. 15 times y equals, and now we have to distribute 6x plus 6y. And what we could do is just subtract 6y on both sides. And if you do 15y minus 6y, that's going to give you 9y is equal to 6 times x. And the goal is to solve for dy dt. So we could divide both sides by 9. And now we have an equation y equals, and simplify this, we're going to get 2/3 x. So what we do at this step now is take the derivative of both sides with respect to time, and we'll make that a little bit neater. So we're taking the derivative of both sides with respect to time. And on the left side, we're going to have dy dt equals 2/3 dx dt. And then remember, we were told dx dt is 4 feet per second. So we're going to have 2/3 times 4 feet per second. And we're running out of real estate here, but 2/3 times 4 is going to give us 8/3. And it's feet per second. And if you simplify that, 8 divided by 3 is going to be 2 2/3, which is going to give you 2.6. So 2.66, and if that goes on forever, we would round it to 2.667. So this is definitely choice B. So question 89 is a massive topic for the AP test. The integral of the rate tells you the net change of the function. So we have an acceleration function here, and we're told the velocity at time 0 is 5. So v of 0 is equal to 5, and we want to know the velocity at t equals 3. So we have to know here the relationship between acceleration and velocity is that the antiderivative of acceleration is velocity. So we could say here the integral of a of t dt from 0 to 3. And the reason why we're using 0 and 3 is because we know what's going on at t equals 0, but we want to know what's going on at t equals 3. And this, the antiderivative of acceleration, is velocity. So that's going to give us v of 3 minus v of 0. So v of 3 is equal to v of 0 plus the integral from 0 to 3 of a of t dt. So v of 0 once again is equal to 5. So we have 5 plus the integral from 0 to 3 of our acceleration function, and the rest is calculator work. So we'll go back to the main screen here, and we're going to have 5 plus the integral. We'll do math 9, and we're going from 0 to 3, and now we're just going to type in the acceleration function. Now the acceleration function was a fraction, so we could do alpha y equals enter so that we make sure we type this in neatly. So what we have here now, we have t plus 3 in the numerator, but we'll use x. And then in the denominator, we had square root t to the third plus 1, but we're going to use x to the third. And I missed the power 3, so we have x to the third, go to the right, plus 1. Just make sure you're typing this stuff in carefully. It's very annoying to lose out because of typos, but in the multiple choice, you're likely to catch a typo. Free response, not as much. So just type carefully. And this is going to work out to 11.710. So 89 is choice E. So for question 90, we have to do a U-substitution, but sometimes to be funny, they'll make you do a T-substitution instead of a U-substitution. So here, just pretend the letter T is the letter U, but we have T equals 2x. So then dt is equal to 2 dx. So what we're going to do is solve for dx. That tells us that dt over 2 is equal to dx. So this is going to be an important piece to plug in, as well as this piece. Now the next thing that we're going to have to replace here are the limits. So notice these are our x equal limits. So we have x equals 6 and x equals 12. So to find the new limits in terms of t, we have t equals, and we plug in 12. We have 2 times 12 is equal to 24. So let's just make that a little neater. So we have the new upper limit will be 24, and the new lower limit, we're going to plug in x equals 6 to our definition of t, and we have 2 times 6 is equal to 12. So now what we do is we're just going to make the substitution. So now we have the integral from 12 to 24. We have f of t, and then dx is equal to dt divided by 2, and all of this is equal to 10. So notice we have the integral from 12 to 24 of f of t dt. So it looks like it's going to be either a or b, but notice there is no divide by 2 here. So what we could do algebraically is just multiply both sides by 2. And now the 2 over 2 is going to cancel, and that tells us the integral from 12 to 24 of f of t dt is equal to 10 times 2, which is equal to 20. So this one's going to be choice B. Question 91, we have f is a polynomial function, and we have values of f prime in the table above. We want to know which of the following must be true from -2 to 6. Well, the key here is to pay attention to the y values, that f prime goes from 3 to 1, which means that f prime is decreasing. And if f prime is decreasing, I'll abbreviate here. F prime is decreasing means that f double prime, the slope of f prime, has to be negative. And if f double prime starts off negative, that means this graph starts off concave down, the graph of f. And then we go from 1 to 4, which means that f prime is increasing. And if f prime is increasing, that means f double prime goes to being positive. And if we have a sign change in f double prime, that means we have a point of inflection. So we have a point of inflection, which we'll abbreviate, on the interval from -2 to 3. Okay, so we have a point of inflection here. And now think about the rest. We go from y equals 4 to y equals 7 in our f prime here. So f prime is increasing again, which means we have f double prime is greater than 0. And then what happens after this? We go from 7 to 5, which means f prime is decreasing. So then f double prime of x is less than 0. So that means that we have another point of inflection on the interval from 3 to 6. So what can we say is definitely true? The graph of f has at least 2 points of inflection. So this is definitely choice B. So for the final question of this section, we're using Cavalieri's principle. We have y equals x squared and we have y equals square root x forming region R. So this we could use a calculator, but these are fairly basic functions. So x squared is going to look like this. And then we have the other function, square root x, looking like this. So region R is going to be this space here. So this is region R. And what we're told is that the cross sections perpendicular to the x-axis, which means they're vertical, are being built into squares. So we're going to take any cross section here, and we're going to drag it off to the side like this. And we're going to turn it into a square. So these are very, very difficult to draw. But if I had to do my best to draw this, see, there's our region, and all of these cross sections here are being built into squares. So I can never imagine what these things actually look like. It's very difficult to visualize, but all I do know is that the squares are really small as we get close to the point 0, 0, and 1, 1, and they're bigger in this middle portion of region R. So whatever this solid here is, this is what we're finding the volume of. But the concept of Cavalieri's principle is that if we could describe the volume of one of those squares, then we could find the volume of the entire solid using calculus. So this part we're just going to call dx. That little change in the horizontal direction is dx. And now the dimensions of this square, we're going to do the top function minus the bottom function. Be mindful that square root x is the top function and we have x squared is the bottom function. So when we're writing out our integrand here, we're going to need to keep that in mind. So we have square root x minus x squared. But now the volume of one of these, be mindful it's a square, so we would do length times width times height, or we would do base times width times height. There's a lot of different ways of saying it, but basically we're going to be doing square root x minus x squared times itself. So we're doing this times this, so we're squaring that, and then times the thickness of this thing is dx. But that would just give us the volume of one of these slices. We want the volume of the whole thing, so that's where the integral comes in, and we're going from x equals 0 to x equals 1. If it wasn't obvious that x equals 0, x equals 1 are the limits of integration, what you could do is set those two equations equal to each other like this. And you could use the calculator for this, but this is going to tell you x equals 0 and x equals 1, which are going to be our limits. And the rest is calculator work. So let's go ahead and type this in. We're going to have math 9. We're going from 0 to 1. And for this part, just be very careful with the parentheses. So inside the integral, we'll do an open parenthesis. We had square root x first. That was the top function. Get out of the square root, and then we do minus x squared. Then we close the parenthesis around square root x minus x squared, and then square it. And then we're going to just write in dx at the end. We press enter, and our solution is going to be 0.129. So that's going to correspond with choice A. Okay, well, this is going to conclude the 2012 Calc AB calculator section. Thanks for sticking out to the end, and good luck on your AP test.